It is Christmas Eve, 1971. In the bustling capital of Peru, 86 passengers are packed into a commercial airliner, eager to get home for the holidays. They board LANSA Flight 508, a Lockheed L-188 Electra. This specific turboprop aircraft was originally designed to fly over flat deserts, meaning its wings are tightly integrated into the fuselage. They are incredibly rigid, completely lacking the flexibility required to absorb severe turbulence. Less than an hour into the flight, a massive expanse of black storm clouds appears ahead. The pilots make a fatal calculation and fly straight in. The cabin goes dark. The turbulence is so violent that overhead luggage rains down on the passengers. Then, at 21,000 feet, lightning hits the right wing, instantly tearing it from the fuselage. At 10,000 feet, the aircraft begins to break apart. Falling from 2 miles up without a parachute means plummeting toward the Earth at terminal velocity. Standard physics dictates that this is a guaranteed, non-negotiable death sentence. The Peruvian government launches the largest search operation in its history. Days pass. When rescue crews finally hack their way into the dense jungle canopy, they find 0 survivors. They only find wreckage, unspooled luggage, and wrapped Christmas gifts dangling from the branches. But miles away from the official search grid, deep in the absolute isolation of the Amazon, a 17-year-old girl named Juliane Koepcke wakes up alone in the mud. She is severely concussed, her collarbone is shattered, and one eye is swollen shut. Yet she is alive. This presents a profound scientific mystery. By what exact mechanism of physics does a human body survive a 2-mile freefall? And once on the ground, how does a half-blind teenager outlive the planet's deadliest biome? This animated diagram reveals the exact physics that kept her alive. Notice these vectors pointing upward. Inside severe thunderstorms, massive columns of warm air, thermal updrafts, rush violently toward the sky. These columns pushed up against Juliane's falling body, creating friction. She was strapped into a row of 3 seats. When that section tore away, the heavy chairs spun rapidly, acting like a helicopter rotor, cutting her terminal velocity. Even at a reduced speed, striking solid Earth would have instantly crushed her internal organs. But the Amazon canopy is incredibly dense. Thick layers of leaves and interwoven vines caught her, acting as a decelerating net that absorbed the final kinetic impact before she touched the forest floor. A 1 in a billion alignment of atmospheric pressure and botany delivered her to the ground alive. But luck evaporates quickly in the rainforest. To keep breathing, science had to take over. Juliane carried a hidden, incredibly specific advantage. She wasn't an ordinary high school student. She was the daughter of 2 prominent zoologists. For 3 years, she had lived with them at Panguana, a biological research station buried deep within the Amazon. She knew how the ecosystem operated. While starving and wandering the dense brush, she found wild mushrooms. A desperate person would have eaten them immediately. Juliane recognized the visual markers of jungle toxicity and refused to touch them, surviving entirely on a small bag of scavenged candies. She applied the same rigorous logic to apex predators. When a massive Goliath bird-eater spider crossed her path, she knew exactly how far to stay back. When an alligator postured to attack her on a sandbank, she waded into the deeper water, knowing that this specific species rarely attacks moving targets in the current. In an environment evolved to consume the weak, her scientific literacy provided a buffer against panic, allowing her to navigate the rainforest with the detachment of a researcher. Her father had drilled a rigid geographic formula into her head. Find a trickle of water and follow it. A trickle leads to a stream flows into a river, and eventually a river will intersect with human civilization. Tracking this water took a catastrophic toll on her body. For over a week, she dragged her shattered collarbone through thick brush and waded through icy currents. Without food, her muscles began to waste away, and open lacerations became breeding grounds for insects. On her 10th day, infected and hallucinating, she stumbled upon an empty logging boat. Inside was a canister of gasoline. 30 flesh-eating maggots had burrowed deep beneath her skin. To stop the infection, she poured the fuel directly into her wounds, forcing the insects to the surface so she could pull them out one by one. Knowledge of biology kept her from the predators, but her survival finally came down to the grit required to perform surgery on her own flesh. On the 11th day, 3 local lumberjacks arrived at the boat. They immediately backed away in terror. Seeing a bruised, blood-soaked girl emerging from the forest, they believed she was Yakumama, a mythic water spirit of the Amazon. She used her remaining strength to speak to them in Spanish, finally securing her rescue. Weeks later, forensic investigators reached the crash site and uncovered a brutal reality. The fall from 10,000 feet was not 100% lethal. 14 other passengers survived the initial impact into the jungle. Every single one of them died on the jungle floor, waiting for a rescue that couldn't see them through the canopy. The contrast between the crash site and Juliane's path proves that impact physics was only half the story. Taking agency and moving forward made the difference between life and death. For decades after the crash, Juliane suffered from severe nightmares, haunted by survivor's guilt. She lost her mother on that flight, and she constantly asked herself the heaviest question of all: why me? Her answer was to get back to work. She returned to university, earned her degree in biology, and became a prominent zoologist. Eventually, she took over the Panguana Research Station, becoming its director. She dedicated her life to studying and defending the exact same wilderness that claimed her mother, destroyed her airplane, and ultimately forced her to live.